Greeting learners, yes, we're gonna continue with our paper. We were doing question 4, now we're gonna go to question 5. Question 5, the graph of f of x is equal to minus 1 over 2 x minus 1 squared plus 8 and g of x is equal to d over x are drawn below. So you can see a point of intersection of f and g is B, the turning point of f. The graph f has x-intercept at negative 3, 0 and 5, 0 and a y-intercept at C. Is the point C. So the first question, 5.1, write down the coordinate of the turning point of f. As you can see, the coordinate, the turning point is here at B. And if we want to get the coordinate of the turning point, we're dealing with the quadratic functions. And to get the coordinate, we will take the bracket x minus 1 is equal to 0. So the first coordinate will be 1. And if x is equal to 1, this will be equal to 0, and the value of y will be 8. So the coordinate of the turning point, 5, 1, b, will be 1 and 8. These are the coordinates of b being the turning point. So I'm going to write the next question that is going to be 5.2. Let me clean the board for the space. Okay, the next question is 5.2. Calculate the coordinate of C. Point C is a y-intercept. So to get the coordinate of C, we will have the first coordinate is going to be 0. So here we'll be having x is equal to 0. We're going to replace x by 0. It will be 5.2 minus 1 over 2, 0 minus 1 squared plus 8. And then we're going to get here negative 1 squared is 1, and negative 1 over 2 plus 8 will get negative 1 plus 2. 2 times 8 here, and we'll be having negative 1 plus 16. We get 15 over 2. So the coordinate of C will be 0, 15 over 2. That is question number 5.2. Coordinate of C is 0, 15 over 2. Question 5.3. Calculate the value of D. The value of D, we can see that here we are having g of x is equal to d over x. This is the equation of a parabola. As you can see here, these are the two branches of the parabola. To get the coordinate, the value of d here, the parabola and the hyperbola are cutting each other at the point B, and the coordinate of B we are having them is 1 and 8. So we're going to replace here writing the functional notation of g of x, y will be equal to d over x. B being a point on this graph, B 1, 8, we will replace x by 1 and y by 8, so we'll be having 8 is equal to d over 1. This will imply that the value of d will be equal to 8. So we can now practically write this equation. G of x will be equal to 8 over x. So we're done with this question 5.2 and 5.3. We're going to clean the board and go to the next question. We still need the graph here so that as we are responding to the question, you can see all the points on the graph. Okay, so we're taking the next questions. 5.4. Write down the range of G. Range of G, as you can see, we're having one branch at the top, the other one is down here. So the range of G, 5.4. The range of G will be Y, it's a real number, and the Y will be different to 0. That is the range of G. There's another way of writing this. We can write from negative infinity to 0, union from 0 to positive infinity. So this is a simple way of writing the range. We're going to the next question, 5.5. For which value of x will this product be negative? F of x times g of x is less than or equal to 0. So if we watch very well our graph, we can see that the parabola is f and the hyperbola is g. The product is negative. It means less than or equal to 0. We can see that is from here, and this other side is also from 5 going to the positive infinity. So here the value will be negative 3. The value of x will be between negative 3 and 0 down here, and the other part will be from here, or x is greater than or equal to 5. So this is the value of x for which the product of these two functions will be negative. I think that's the answer for 5.5. We're gonna continue with the next question. We will clean the board so that we can write the next question. Okay, here is the next question. 5.6. Calculate the values of k so that h of x is equal to negative 2x plus k will not intersect the graph of g. So here we will be having that h of x is equal to negative 2x plus k, and they want us to get the value of k so that this function will not intersect the graph of g. So here we'll be having negative 2x plus k will be equal to 8 over k, and then we will get the value of k so that it will not intersect the graph of g. Crossing, multiplying, that we're going to get here negative 2x squared plus kx. This is going to be equal to 8. X will be a common denominator. So we'll get negative 2xk plus kx minus 8. This will be equal to 0. So we're going to try and get the value of k, and this being a quadratic function, we'll try and get delta. Delta is b squared minus 4ac. So here it will be k squared minus 4. The value of a is negative 2, and the value of c is negative 8. So it will be k squared. 8 times 8, we're going to get here negative 64. And our delta must be negative for h of k not going to be intersecting the graph of g. So it will be like this. And if we want to factorize here, we'll get two values of k, because this being the difference of two squares, it will be k minus 8 and k plus 8 greater than 0. less than 0, sorry. And then the value of k will be plus minus 8. And if we study the sign of this quadratic equation k squared minus 64, we will get that our k will be between negative 8 and 8. So if I want to explain a little bit for this, we're going to have the value of k here. Here it will be k squared minus 64, negative 8 plus 8, like as we are having the number line 0, 0 here, and outside the critical value will have the sign of k being positive, and in the middle it will be negative. So it's a negative between negative 8 and 8. So the value of k is between negative 8 and 8. So we're done with question 5-6. We're going to take the last question 5-7. Okay, so here's the last question for question 5-7. H is a tangent to G at R, a point in the first quadrant. Calculate T such that Y will be equal to f of x plus T intersect G at R. So here's our G in the first quadrant. We're going to have a tangent somewhere here. So this will be considered to be a point R. Our tangent will have this form passing at the point of contact. So they want us to calculate T so that Y will be equal to f of x plus T if this is going to intersect G at this point. The tangent will be passing here at the point of contact. So 5-7, to get the value of T, we will need first to equate these two equations. We know that h of x, it was negative 2x plus 8, and the equation of g of x is 8 over x. By solving this, we're going to get the point of contact, and this is going to be the coordinate of r. So we'll be having negative 2x squared plus 8x is equal to 8. Negative 2x squared plus 8x minus 8 will be equal to 0. We're going to divide by negative 2, so it will be x squared minus 4x plus 4 is equal to 0. And this is a perfect square. X minus 2 squared, we will be getting x squared minus 4x plus 4. Then x will be equal to 2. Then we'll come back here in h of x to get the value of y, because h of x is equal to negative 2x plus 8. If we replace x by 2 here, we will get negative 4 plus 8, and y will be 4. So negative 2 times 2 plus 8 would be negative 4 plus 8, and the value of y would be 4. So the coordinate of R, point of contact, will be 2 and 4. Now, we will come back here and replace x by 2 and y by 4. So we're going to have here 4 is equal to, in f of s, negative 1 over 2, 2 minus 1 squared plus 8. And this is going to be plus t. So let's use a calculator. We will be getting this value here, 4 minus this value, and then the value of t will be easy to get. So here we are having 2 minus 1, 1 squared is 1, minus 1 over 2 plus 8. Then we're going to get 4 is equal to minus 1 over 2 plus 8. Then we get 15 over 2 plus t. So t will be equal to 4 minus 15 over 2. And that will give us negative 7 over 2. That's the value of t. So we can see by replacing y by 4 and x by 2 here, the value of t is going to be negative 7 over 2. So we're done with question 5. We now are going to go to the next question, question 6. And let's clean the board. Yeah. Okay, so we're taking now question 6. Question 6 is dealing with financial mathematics. So the first question, 6.1. Patrick deposited an amount of 18,500 into an account earning 8% interest per annum, compounded monthly. After 6 months, his balance was 19,319.48. And the question is calculate the value of R. So R is representing here the interest rate. So here, as you can see, we'll be using a formula for calculating the interest rate. And that formula is A is equal to P times 1 plus I to the power of N. And A is the accumulated amount, and P is the present amount, I is the interest rate, and N is the number of compounding periods. So the value of A is given. So we're going to take question 6.1.1. The value of A is given 19,319,18, and this will be equal. The value of P is given, is here, the deposited amount. So it's 18,500, 1 plus R over, R is the percentage, so we're going to divide this by 100. And remember, they are saying here is compounded monthly. So it's going to be R percentage, R over 100 divided by 12. So here we'll be getting 1,200. This will be at the power of 6, because they say after 6 months, the balance will be this. This is the accumulated amount. So we're going to calculate the value of R here. We will definitely going to need a calculator. So here we're getting 1 plus R over 1,200 to the power of 6. This will be equal to, we're going to take a calculator. We'll have this value here, 19,319 divided by 18,500. So this is what I'm going to do with the calculator. 19,319.48 over 18,500. So what are we getting? Here we need to use a calculator. So we'll be having 19,319.48 divided by 10,500. So we're getting this value. I'm going to write this value here. 1,044. And then we have got 296. I'm going to round it off to 30. Yeah. So we will be getting here that 1 plus r over 1200, this will be equal. We're going to take the sixth root of the left side, and also going to be the same on the right side. So it will be root 6 over 1,044 30. And as you can see, this side we are having plus 1. This will be transposed to the other side. So we'll be having, I can write it up here, r over 1200 will be equal to the sixth root over 1,044 minus 1. And the r will be equal to 1200 multiplied by this square root, sixth root over 1,04430 minus 1. And then we will get the value of r using our calculator. Use our calculator. 1200 multiplied by the sixth root over 1,04430 minus 1, close the bracket, and then we're getting 8,7007. So the final answer is 8,7%. So this is the value of r. We are done with the first question. The value of r is 8,7%. We're going to clean the board. Then we're going to go to the next question. That is going to be 612. Okay, we're going to the next question. Is 612. Calculate the effective interest rate. So here, remember, we're having a formula. If we want to convert the nominal interest to the effective interest rate, we're having a formula here. The formula is 1 plus I effective, and this is going to be equal to 1 plus nominal over m to the power of m. M is the compounding period, the number of compounding period. So we know that we'll be having 1 plus I over 100 is going to be equal to 1 plus, we got already here the interest rate, so it's going to be 8,7. We're going to divide by 100 and divide by 12 because it's compounded monthly, so it will be over 1,000 and to the power of 12. So here we want to get the effective interest rate per annum. So how are we going to do this? We will say we're going to take the 12 root of both sides. So it will be 1 plus I over 100 is going to be equal. I'm going to take this value and into bracket and use the calculator. How much are we gonna get? Oh, let me do this so that it's gonna be easy. Yeah, I over 100 will be equal to 1 plus 8,7 over 1,200 to the power of 12 minus 1. Yeah. Then I'm gonna clean the board here to continue. To get I, I'm going to multiply by 100 both sides so that I'll be having I is equal to, are we gonna have enough space here? 100 times 1 plus 8,7 over 1,200 to the power of 12 minus 1. So here I'm just going to take the calculator. 100 multiplied by 1 plus 8,7 over 1,200, and then close the bracket to the power of 12 minus 1. And what are we getting here? So we're getting 9,055. I'm going to round it off to 9,06. So our I will be equal to 9,06%. This is the effective interest rate. So then we are done with question 6.1. I'm going to clean the board so that we can go to the next question. That is going to be 6.2. This was 6.1, 6.11, 6.12. Now we're going to go to 6.2. Okay, the next question is 6.2.1. So 6.2. Kunda bought a laptop for 10,000 or 31st January 2018. We'll replace it with a new one in 5 years' time on the 31st January 2024. 6.1. The value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0 rand? So here, for the straight line method of depreciation, the formula is A is equal to P times 1 minus IN. So the value of A is given here. It will the laptop have a value of 0. 0 will be equal. The value of P is given is 10,000. 1 minus, and the value of I is 20%. 20 divided by 100, we're getting 0,2n. So we're going to try and get the value of n here. So 10,000 multiplied by 1 minus 10,000 times 0,2. How much are we getting? 10,000 multiplied by 0,2. Then we get 2,000. 2,000 times n, and this will be equal to 0. So we'll be having that 2,000 n will be equal to 10,000, as you can see. Now n will be equal to 10,000 divided by 2,000, and then our n will be equal to 5. After how many years will the laptop have a value of 0 rand? It's going to be after 5 years. So I think we are done here with the question 6.1. We will continue next time. There are 2 more questions remaining. Thanks for watching, and don't forget to subscribe and share, comment, and if you have learned something, share. Thank you. Thank you. Bye.